Let's solve this implicit differentiation problem step by step. We need to find dy dx. Given that 3x to the fourth minus x squared, y plus 2, y cubed equals 0. To solve this, we'll use implicit differentiation, which means we'll differentiate both sides of the equation with respect to x, treating y as a function of x. Let's start with our original equation. Now, let's differentiate each term. For 3x to the fourth, the derivative is 12x cubed. For negative x squared, we need to use the product rule. This gives us negative 2x, y plus x squared times dy dx. For 2y cubed, using the chain rule, we get 6y squared times dy dx. Let's group all terms with dy dx together on one side and move all other terms to the other side. This gives us 6y squared minus x squared times dy dx equals 2x, y minus 12x cubed. Finally, we can solve for dy dx by dividing both sides by the coefficient of dy dx. This gives us our final answer. Dy dx equals 2x, y minus 12x cubed, all divided by 6y squared minus x squared. Let's review the key steps we used. First, we used implicit differentiation to differentiate both sides. Then we used the product rule for the x squared y term and the chain rule for the y cubed term. Finally, we grouped like terms and solved for dy dx. This problem demonstrates the importance of knowing both the product rule and chain rule when doing implicit differentiation. Remember that when y is a function of x, we need to include dy dx whenever we differentiate terms containing y.